let's go through LeetCode 636 exclusive time of functions. For this question, it give us an number n, which means there are n functions. Each function will have an ID from 0 to n-1, and also a list of logs. The log will have this kind of format. For example, the first one is function ID, and followed by a comma, and followed by a flag that it is start or end, and then followed by a comma, and followed by the time. It let us to calculate for each function its exclusive time. So we can see for the function 0, it start at index 0, and then at index 2, there is function 1 join. So function 1 will start 2 to 5. There are 1, 2, 3, 4, 4 time units. And the function 0, 0, 0, 1, and 6. So there are 3 units. So the result will return 3 and 4. For this question, we are going to use a stack and trying to push the function index into the stack, so that when there is new time events coming, for example, it is a start. We just, for example, at the beginning, there is 0 coming. We push 0 to the stack. And when there is function 1 start, we just push 1 into a stack. When there is an end, we just pop it out. And also, we calculate the function 1's time. And also, we pick trying to see what is the function ID of this one. And when there is another end event, we calculate the next part, like this part, and add it to the function 0's exclusive time. So as we talk about, we need to array as a result equals new int n. We need to have a stack. Use this stack to store the function index. Okay, we are going to use a variable called last time. Int last time equals 0. So let's iterate the logs. For string logs. I'm going to split the logs into segments. So int function ID will be integer plus int zero, and the string we call it event, so can be start or end, like be segment 1. And and also the time. So we are also use a integer called time. Not be integer plus int 2. So we need to see whether this event is a start event or an end event. So if event equals start, else. So if this equals start, we try to see whether there is any already any function ID already being in the stack or not. So if there is some kind of function ID in the stack, we need to calculate this time for them too, and the previous start time, like 0, will add it to the previous function. Yeah. So let's write. So if this one equals start, we check if stack isn't empty. If this isn't empty, we'll get pre int pre-id pre-fid equals stack dot pick. Why we use pick? Because we don't want to pop it. We'll pop until we have the end event for the previous one. So we want this one still be in the stack. We want to pop it until to this kind of point. So stack pick, and we'll have a result pre-fid plus equal to plus equal to time minus last time, and we'll also update last time to be time. So, and also this is if it's not empty. No matter is it empty or not, we need to have push the function ID to the stack push ID. We can put the last time equal time here because if it is empty, we also need to update the last time. So this is start event. So if it's the end event, if it is the end event, the stack will not be, because if there is an event for this kind of log, there must have a start event. So in the previous sometime, there must push some kind of FID to the stack, so it will not be empty. So we just just int ID. We use the FID already. ID equals stack dot pop. So for example, this is 5 at the time 5. It pop this ID, and we know the last time for so this is ID is the last time for this is 2. We need this is last time, and this is current end time. So we need to have result ID plus equal to time minus the last time plus 1. Okay, so we need to update the last time as well. For every last time, we need to move to 6, right? So we'll have the last time equals to time plus 1. So this is end events. So we just return result. So for this question, we use stack as a data structure in the return array. It is a linear operation, so the times and the space complexity is O(n).